Hey Geometry kids, this is our last lesson of chapter 6. Can you believe that? Whew, we're getting through quadrilaterals. Our last lesson has nothing to do with parallelograms. So do not get trapezoids and kites mixed in with the past 5 lessons. They have different qualities and they are not considered a parallelogram. So all those conditions that we have been talking about do not apply to these. These two shapes, however, are quadrilaterals, which means they have 4 sides. Now, a trapezoid, you may know what that looks like. It has 1 pair of parallel sides. Just 1, not 2. A kite, which looks just like the kind of kite you probably used to fly when you were little, is a quadrilateral. It has no parallel sides, but it has 2 pairs of consecutive, that means next to these 2 sides here and these 2 sides over here, sides. So think about a kite that you fly. A good kite is made just like that, 2 pairs of consecutive congruent sides. Now, example 1, we're going to talk about isosceles trapezoids because these are special. That means that JM and KL are congruent. That not only is this a trapezoid in that its base are parallel, but it also means that it has 2 legs, that's what we call those, sides, that are also congruent. So we know that the measure of JML, this big angle down here, is 130 degrees. We also know that KN is 6.7 feet, and MN, this little piece, is 3.6. We want to find the measure of MJK, this angle way up here, okay? Well, the cool thing about isosceles trapezoids is that the measure of angle JML, this bottom angle, is the same as this bottom angle, MLK. Now that is cool because that means that these 2 angles are supplementary. And that is by theorem 6.21. So to find MJK, let's subtract 130 from 180. And we get 50 degrees. Awesome. Next we want to find JL, this diagonal right here. Again, because this is isosceles, if you think about this as a triangle, these 2 angles are the same, these 2 sides are the same, and this side is reflexive, so these triangles are the same. So JK, or MK, is going to be the same as JL. JL is the same length as MK. So we got to just add it up. 3.6 plus 6.7 equals 10.3. And that's theorem 6.23 in your book. Okay, number 2. Go ahead and plot your points on that graph. Okay. We have here a quadrilateral that appears to be isosceles. We do know that it is a trapezoid. Well, actually, we need to show that it is. We don't know that yet. It appears that it is. But in order for it to be a trapezoid, we need to see if CD is parallel to AB. So in order to do that on a graph, we're talking about slope. So first, prove ABCD is a trapezoid. That means that CD, is that parallel to AB? Well, let's check it by checking the slope. The slope of CD is 1/4. Very good. What is the slope of AB? It's also 1/4. Now, our, what do you call those? Conditions say that it has to have only one pair. So even though these are not parallel, we need to state that by showing the slope. Slope of AD, -1. Slope of BC, yes, 4/1, which is 4. So you can see right here from our math, it has one pair of parallel lines. So ABCD is a trapezoid because it has one pair of parallel lines. Okay, we also want to determine whether or not it's isosceles. So that means we want to see if CB is the same length as AD. So we want to see, are these congruent? So ABCD, is this isosceles? In other words, does BC equal AD? In order to find that out, we need to find the distance. Let's do the distance of BC first. Use distance formula. And let's go ahead and evaluate. You should get the square root of 1 plus 16, which is the square root of 17. Let's find the distance of AD, just to make sure, because it looks like they're the same. But let's double check. Okay, go ahead and simplify that. We get the square root of 9 plus 9, which is the square root of 18. So, those are not congruent. BC is not equal to AD. Therefore, yes, this is a trapezoid, but no, it is not isosceles. Okay, turn the page, and let's talk about mid-segments. A mid-segment, just like a midpoint, that means that this mid-segment MN is halfway between these two. So if you think about it, if this is 20, this is 30, this line down here, JG, is going to be twice as much as KF. So there's a formula for that. This mid-segment formula, MN, is always half of the average of your two bases. Half of KF plus JG. That's your formula, always. So let's substitute in. MN is 30. KF is 20. And JG is X. Now you need to know this formula. Even though this example is pretty easy, you need to know the formula in case you get something harder. So get rid of that 1/2. Multiply both sides by 2. And let's solve for X. And X equals 40. That means JG is 40 units long. Okay, example 4. Letter A. Find the measure of angle XYZ. This angle way over here. So we have only 2 angles. Well, the cool thing about kites is that angle X is always congruent to angle Z, because this right here and this right here is the same. If I drew a line down here, I have 2 triangles side, side, side. Therefore, these angles are congruent. So angle Z is also 121, even though they don't tell you that. How many degrees are in a quadrilateral? If you said 360, you are right. So we can set up a simple equation. 360 minus 121 plus 73 plus 121. And angle Y, or angle XYZ, you should get 45 degrees. Excellent. So another cool thing about kites is not only are its angles kind of neat like that, but you have these diagonals here that form right angles. They make a perpendicular lines. And this line right here, MP, it is bisected. So that means if MR is 8, what other side is 8? Yeah, RP is also 8. I want to find NP, this side over here. That looks a lot like a Pythagorean triangle. If I pull that triangle out, I have legs that are 6 and 8. I can use Pythagorean theorem. 6 squared plus 8 squared. Oops, getting ahead of myself. 6 squared is not 64. Take the square root, and you should find that NP is 10 units long. Okay, use what you know about kites, what we just discussed in example 4, to find the measure of ADC, this big angle right over here. Think about what other angle it is congruent to. And good luck. See you on Monday.